There is a difference between power and energy, and almost nobody selling you storage explains it. Energy is how much you have, power is how fast you can move it. A battery is excellent at the first and poor at the second. A $50 washing machine drum is the exact opposite. Spun to its factory speed, that drum holds about 1 watt-hour, a 15th of a phone charge. But it can hand all of it back in half a second, which works out to over 6 kilowatts of instantaneous power. It contains no lithium and no chemistry at all. It runs 150,000 full cycles without degrading, at any temperature, with nothing inside that can catch fire. New York State balances its grid frequency with 200 of them. It is called a flywheel. By the end, you will know exactly what it stores and how to build one safely. Let us dive in. Your battery bank is not killed by the lights. It is killed by the moments. The steady loads barely register. A string of LED bulbs, a router, a laptop on the counter, those draw a couple of amps and hold there for hours. That is the easy part of the job, and any bank handles it. The damage arrives in bursts. A well pump kicks on and demands several times its running current for a second or two. A refrigerator compressor starts. A power tool spins up. In that instant, the load spikes far beyond anything the system sees the rest of the day. And your bank feels every one of those. The voltage sags under the surge. An undersized inverter reads that sag and trips, cutting power to everything in the house. The cells heat up, and each of those events takes a bite out of a component that is rated for a finite number of cycles and nothing more. Meanwhile, a lithium wall is counting anyway. It degrades on a schedule whether you surge it or not, losing a fraction of its capacity every year it sits there. So what does everyone do about it? They oversize. They buy a bigger bank and a bigger inverter. Thousands of dollars of extra kilowatt hours they will never actually consume purely to survive a handful of seconds that arrive a few dozen times a day. You are buying a reservoir to solve a plumbing problem. And there is an object sitting in the scrapyard that was built for nothing but surges. A washing machine drum spends its entire life doing one thing, getting heavy with motion and then refusing to stop. Look at what it actually is. A balanced stainless steel cylinder, engineered to spin at around 1,400 revolutions a minute, loaded with wet laundry, thousands of times, without tearing itself apart. That is a serious piece of rotating hardware, and somebody already paid to design it, balance it, and test it. Spin it up, and it holds that motion. Slow it down, and it hands the motion back. There is no chemistry inside it. Nothing to age on a shelf. Nothing to count down. Nothing that can catch fire in your garage at 2 in the morning. It performs exactly the same at 40 below as it does in August. It is not a battery. It never degrades, and that is the part no battery can copy. So the obvious question is how much a spinning drum actually holds. The energy in anything spinning comes from a single line of physics. 1/2 times the moment of inertia times the speed of rotation squared. 2 terms, and both are worth understanding. Moment of inertia is how much mass you have and how far out from the center it sits. That second part matters enormously. Mass at the rim counts far more than mass near the hub because it travels farther and faster for every turn, which is exactly why a drum is the perfect shape. Nearly all of its steel is out at the edge, doing the most work it possibly can. The other term is rotation speed. And notice that it is squared. Double the speed, and you quadruple the energy. Hold on to that. It becomes the most important safety fact in this video. So let us run the real numbers. A stainless drum weighs somewhere around 5 kilograms, with a rim radius near 1/4 of a meter. That gives a moment of inertia of roughly 0.31. At its factory speed of 1,400 revolutions per minute, It is turning about 147 radians per second. Half of 0.31 times 147 squared comes to about 3,360 joules. Convert that to the unit on your power bill and you have 0.9 watt-hours. Call it 1. That is a 15th of a phone charge. In a drum you can barely lift. Now watch what happens when you divide by time, because power is simply energy delivered per second. Release those 3,360 joules over half a second and you have just delivered more than 6 kilowatts. That is more instantaneous punch than most home battery walls on the market can produce. A battery is an energy device that gives up power grudgingly. A flywheel is a power device that holds energy briefly. They are not the same product. One honest weakness before we go on. A weight raised on a rope holds its charge forever. A spinning drum does not. It bleeds energy continuously into bearing friction and air drag, and it coasts down on its own whether you use it or not. That is precisely why serious flywheels run inside a vacuum on magnetic bearings. Getting the energy back out is the easy part, because a motor spun backwards is a generator. And none of this is new. This is the oldest energy storage device human beings ever built. Before the battery, before the dam, before the boiler, there was the potter's wheel, a heavy stone disc mounted on a spindle. The potter kicked it once, and the disc absorbed that kick and paid it back as smooth, steady rotation for a minute or more. That is energy storage, the first that human beings ever built, thousands of years before anyone had a word for it. And it is the same principle you are holding when you spin a drum. The industrial leap came with steam. When James Watt's engine drove a piston, the power did not arrive smoothly. It arrived in violent pulses, a shove, then nothing, then another shove. That is useless for driving machinery, which needs steady rotation. So engineers bolted a heavy flywheel to the shaft. It absorbed each pulse and released it evenly, turning a hammering piston into a smooth turning line. That is what allowed the steam engine to run factories. Read that job description carefully, because it is exactly the job in this video. The flywheel was never the fuel. It was the smoother, standing between a lumpy source and a steady load. Then somebody tried to promote it. In 1946, Bjarne Storsund, chief engineer at Maschinenfabrik Oerlikon in Switzerland, designed the Gyrobus. It was a passenger bus with no engine and no overhead wires, powered entirely by a flywheel weighing 1.5 tons and measuring 1.6 meters across, spinning at 3,000 revolutions per minute, inside a sealed housing filled with hydrogen at reduced pressure, purely to cut the air drag, stealing its energy. Commercial service opened in October 1953, running between Yverdon-les-Bains and Grandson. At each charging stop, booms went up, and the flywheel spun back to speed in 30 seconds to 3 minutes. Then the bus drove about 6 kilometers. It worked. Technically, it genuinely worked. And it died commercially on electricity consumption and parts costs. The last one ran in 1959. A single survivor sits today in the Flemish Tram and Bus Museum in Antwerp. 1.5 tons of steel for 4 miles. The flywheel spent 2 centuries succeeding as a smoother, and failed the very first time somebody asked it to be a fuel tank. And the moment the modern grid needed something faster than a battery, it went straight back to the flywheel. In Steventown, New York, 200 steel cylinders spin in the ground, and they hold up the frequency of an entire state's electricity. The company was Beacon Power, and the plant reached its full 20 megawatts in June of 2011, the world's first grid-scale flywheel storage facility. It sells frequency regulation into the New York system operators market. That is the second-by-second balancing act that keeps the grid sitting at 60 Hz, correcting constantly as demand and supply drift apart. Now, here is the specification that explains this entire video. Each Gen 4 flywheel is rated at 100 kilowatts of output and 25 kilowatt hours of storage. Read that ratio again. It can pour out everything it holds in 15 minutes. On a battery spec sheet, that would look like a defect. Here it is, the product. Nobody bought those flywheels to store energy overnight. They bought them to move power fast. And fast is the point. The plant reaches full output, up or down, in under 4 seconds after receiving a control signal. That is roughly 100 times faster than conventional generation can respond. Then come the durability numbers, and these are the ones no chemistry on Earth can match. The system operates at 100% depth of discharge with no energy degradation over time. It is rated for more than 150,000 full charge and discharge cycles. It is built to last 20 years or more, with virtually no maintenance required in the mechanical portion. And in service, it demonstrated availability above 97% higher than the average conventional generator doing the same job. Sit with the second one for a moment. Drain it completely, 150,000 times, and the machine is unharmed. Do that to a lithium wall, and you would destroy it in a fraction of that count. So if it never degrades, and it responds 100 times faster than anything else on the grid, the fair question is why there is not one in your house. Nobody buried the flywheel. It is the oldest storage device humanity has. It is spinning under New York right now, and its own maker still went broke. Beacon Power filed for bankruptcy in late 2011, only months after that plant reached full capacity. And the reason was not that the flywheels failed. They performed exactly as advertised. The reason was the market. Storage markets pay for kilowatt hours. Flywheels sell kilowatts. When the contracts are written around how much energy you can hold, rather than how fast you can move it, a machine built for speed is competing in the wrong category. And underneath all of it, lithium prices were collapsing, taking the margin with them. Now run the arithmetic on your own house, because it is the same mismatch in miniature. A home needs to run overnight. That is an energy job, measured against the roughly 30 kilowatt hours an average American house burns in a day. A scrap washing machine drum holds about 1 watt-hour. That is millionths of what a house consumes. A flywheel will never run your home overnight, and no clever design fixes it, because energy depends on mass and the square of speed, and you have neither to spare in a 5-kilogram drum. Nothing here was suppressed. The flywheel is simply the wrong tool for a job it was never applying for. But now look at what it actually owns, because this is where the title becomes completely honest. Instant response, measured in milliseconds. Complete discharge with no harm whatsoever. Over 100,000 cycles with no degradation. Total indifference to temperature. No chemistry that can burn. And no cycle counter quietly ticking down while it sits in the corner doing nothing. Those are precisely the 6 things batteries are worst at, every single one. Which means a flywheel and a battery were never competitors. They are a pairing. The battery holds the night. The flywheel takes the hits. A battery sells energy. A flywheel sells power. It is not a smaller battery. It is a different position on the field. So here is the build that uses a drum for the job it has held for 250 years and the 4 rules that keep it from killing you. This build does one job, and it is Watt's job. It stands between a lumpy load and a bank that hates surprises. If you want the full build, the containment check, the motor wiring, and the controller settings, we put together a complete walkthrough covering everything in this video and more. The link is in the description below. Here is the build in order. First, and this is not negotiable, leave the drum in its tub. Do not pull a bare drum out and mount it on a shaft in the open. The washing machine cabinet and the outer tub around that drum are containment, engineered and tested for that exact drum at that exact speed by people who did the math. It is the only certified containment you will ever get for free, and you already own it. Second, keep the machine's own motor. Ideally, you want a direct drive permanent magnet type, like the Fisher and Paykel Smart Drive. That is a genuine three-phase permanent magnet machine, which means it is a genuine generator the moment you drive it backwards. It is the reason people have been salvaging these for wind turbines for 20 years. Third, wire it through a three-phase rectifier into a controller that can work in both directions, spinning the drum up and harvesting it back down. Fourth, charge it from surplus, midday solar, or a healthy bank with headroom. Bring it up to its factory speed and never past it. Then comes the payoff. When a surge hits the pump starting, the compressor kicking in the controller pulls the drum down and dumps kilowatts for the second or two the load actually needs. Your inverter does not trip. Your battery never sees the spike. The steel takes the hit instead. Now the 4 rules, and these are the section. 1. Never exceed the original design speed. Energy climbs with the square of speed, so doubling the RPM quadruples the stored energy inside a housing rated for none of it. The history here is not ambiguous. Industrial flywheels holding as little as 5 kilowatt-hours have burst and destroyed the buildings around them. In 1995, a spin test killed the operator on a unit storing under 1 kilowatt-hour. 2. Never modify the drum. No drilling, no welding, no added mass, no clever counterweights. Balance at speed is everything, and a small imbalance becomes a violent one very quickly. 3. Keep the electrical side loaded and fused. A smart drive is docile at 48 volts. Spun fast with its output open, it can reach around 1,500 volts with enough current behind it to kill you. Never spin it disconnected. 4. Treat spin down as live. The drum keeps its energy after you cut the power. No lid opens until it has fully stopped, and nobody stands in the plane of the rim while it is running. This is the only build on this channel where the failure mode is measured in fragments. Respect all 4. A drum flywheel stores about 1 watt-hour, and nothing you do to it changes the order of magnitude. It will not run your house. It will not run your refrigerator. It will not carry your lights through an evening. And unlike a weight hanging on a rope, it does not even hold what it has. It bleeds into friction and air drag and coasts down on its own, whether you draw from it or not. That makes it a buffer, permanently, and never a reservoir. It is bounded by mass and speed, and the drum's own designers fixed both of those numbers for you. But here is what it gives you that your battery cannot buy at any price: a component that absorbs surges forever at any temperature. With no chemistry, no fire risk, and no cycle counter running down in the background. Every hit it takes is a hit your expensive bank does not take. The oldest energy storage device human beings ever made is still doing the exact job it did for James Watt, standing between a lumpy source and a steady load. And knowing power from energy is the difference between buying the right machine and simply buying a bigger one. If discovering the practical, unglamorous corners of energy self-reliance matters to you, subscribing and sharing is the simplest way to make sure this kind of knowledge keeps being found. We will be tracking all of it as it develops. So here is the question. Would you put $50 of scrap steel between your bank and every surge in the house for 20 years with nothing to degrade? Or would you spend another $1,000 on battery capacity bought purely to survive 2 seconds at a time? I would genuinely like to know. Drop it in the comments.